Okay, so then that brings us to the second part of this first section in Chapter 2, which is scientific notation. And once again, this is something that you guys are probably familiar with. Okay, scientific notation is kind of designated in the following form: C times 10 to some power. Call it n. Okay, the restrictions on C is C has to be a positive number. Right, it's going to be at least one digit beyond the decimal. So we're going to say that C has to be greater than or equal to 1. And it has to be some number that is a single digit. So the restriction with the single digit would be has to be less than 10. Can't equal 10. And this restriction right here simply tells you that there's one decimal place or one digit in front of the decimal place. Okay. So if you have something, now scientific notation is used for extremely large, extremely small numbers. Usually it's inefficient to use for a number like 100 or 234. But if you take some number like this, scientific notation allows a more efficient way to express this relationship or this number. And the way that it does is you take all the digits that fall either before or after the zeros. So here we have these two digits, 3 and 4. You're going to place the decimal between or after the first digit. Bless you. That guarantees it fits this restriction of one digit in front of the decimal. And then you're going to look to see how many, by powers of 10, how many decimal places do you have to move this in order to represent the original number. And so if you just imagine, here's where the decimal is in your notation. How many places do you have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And it's 9 places to the right. To the right in the number line is a positive number. So that becomes your power of 10. So 3.4 times 10 to the 9th would be your expression of this. If you have extremely small numbers, so something like the following. You can express this using scientific notation as well. The rule is nearly identical. You take all the digits that fall before or after the 0. So 7, 2, and a 1. Place the decimal point after the first. And then again, back on your original number, here's where you're placing your decimal. Decide how many places do you have to move. 1, 2, 3, 4 to arrive at the original decimal. So this is 4 to the left is a negative direction. And so when you find your power of 10, you're going to use that negative 4 to represent scientific notation. Okay. Now, your calculators can do this, but keep in mind I'm asking you to make sure you can solve these types of problems without using your calculator. Okay. And the way that you can do that is if you look at the sample problem number 6 on page 13. These are the types of problems that you should be able to answer without using a calculator. Does it seem like you could? Okay, let's go through. I want to go through the first example, and then I'll have you do the second one on your own. Okay, so let's look at this first example. I'm going to move these into a new page here. All right, in this first example, let's write all the numbers in terms of scientific notation. Okay, so what would 50 million be? 5 times 10 to the what power? 1, 2, 3, 4, 5, 6, 7. Okay, and then this second number, we only have one digit after all the zeros. And let's see, how many places would we move the decimal here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 in the negative direction. And that's all divided by, if we take just 20,000, we have one digit in front, 2 times 10 to the 1, 2, 3, 4. And that whole thing is cubed. And now, once you get it into this scientific notation form, you can now apply the rules of powers that we just looked at in the early part of this section. Okay. What is 5 times 6? 30. What is 10 to the 7th times 10 to the negative 10th? 10 to the negative 3rd. When you multiply two numbers with the same base, you add their powers. Now we can cube each part of this. This power of 3 applies to all factors inside this grouping symbol. So what is 2 cubed? 8. And what is 10 to the 4th cubed? 10 to the... When you take a power to a power, you multiply. And so now what you could do here is you can reduce this number. What goes into both 30 and 8? 2 goes into 30 15 times, 2 goes into 8 4. And so you wind up with, and you can take 4 into 15. 4 goes into 15 how many times? 3, with what remaining? 3 remaining. 4 goes into 30 how many times? 7, with what remaining? 2. 4 goes into 20 5 times. So you get 3.75 times 10 to the, and when you divide two numbers with the same base, what do you do with their powers? Subtract what's negative 3 minus 12? Negative 15. And so here is your solution. Right now, if you were going to use a calculator to verify this, you could test it. I'm going to go ahead and just do this calculation so you can see, once again, if you're unfamiliar with how to enter scientific notation. But if we take 5 times 10 to the power of 7, this EE button right here, the third button on the left from the bottom, and it's going to display as just an E. That letter there and that button represents times 10 to the power of whatever you type next. And so 5E7 represents 5 times 10 to the 7. We're going to multiply that by 6e to the negative 10. And then we're going to divide that by the entire quantity 2e to the 4th. And that will be taken to the power of 3. Hit enter, and you see that it verifies 3.75 e to the minus 15. It confirms that we have the right answer. I want you